Simcenter 3D supports many capabilities that are critical to the aerospace industry, and in this demonstration, we'll compare the structural performance of two wing designs. We'll begin by reviewing the results of the base design. Simcenter 3D offers an integrated simulation environment with embedded multidiscipline solvers, including the NX-Nastran solver. NX-Nastran was used to perform a modal analysis of the wing assembly FEM to make sure all the components were included properly and connected correctly. Using Simcenter 3D post-processing template speeds up the process and ensures consistency when reviewing results from engineer to engineer and analysis to analysis. Now let's take a look at the proposed new wing design, which includes a winglet. Using Simcenter's assembly FEM tool, otherwise known as AFEM, we can see one of the components hasn't been meshed or added to the finite element assembly model. This can easily be rectified by mid-surfacing the imported CAD geometry. And notice that the mid-surface component is non-manifold and needs to be stitched prior to meshing. In other CAE tools, this would be a manually intensive process involving meshing existing unstitched geometry and then reconnecting nodes and elements one by one. In an integrated solution such as Simcenter 3D, the CAE engineer instead fixes the geometry prior to meshing and can also use geometry cleanup tools to further improve the quality of the mesh and hence the accuracy of the CAE results. Once the AFEM is complete, we will set up an analysis and map the CFD pressure results to a boundary condition and map them to the wing assembly. So the CFD results are used as inputs into the next phase of the analysis process. Keeping in mind that all of the tools you're seeing, geometry editing, meshing, solving, are all integrated into one environment. Once the mapping process is completed, we can review a contour plot of the pressure boundary conditions. This is a good sanity check to perform before solving the analysis and possibly looking at erroneous results. Then let's look at the wing design with the winglet in greater detail. If needed, these results could be used for subsequent fatigue analysis. But for now, let's focus on comparing the results of the design with the winglet to the base design. As you can see, the stress in the design with the winglet is slightly higher than in the base design. This is to be expected as the winglet is creating more lift and hence has more total force acting on the wing. Simcenter 3D can help you speed aerospace simulation processes through a unified environment that is more efficient than traditional CAE tools for pre- and post-processing, as well as multidisciplinary engineering.